So here we have to find all the points of discontinuity of the function f of x defined by mod x minus mod of x plus 1. So that will be equal to, so when x plus 1 is less than 0, means x is less than minus 1, then this will be minus x and this will be minus of minus x plus 1, that is plus x plus 1. So this is when x is less than minus 1, and when x is greater than or equal to minus 1 and less than 0, then we can say this will be minus x and this will be minus of x plus 1. And when x is greater than 0, when x is greater than or equal to 0, x is greater than or equal to 0, then we can say it will be x minus of x plus 1. So this will be equal to minus x plus x, that will cancel out. That will be 1 if x is less than minus 1, and this is minus 1 minus 2x when x is greater than or equal to minus 1 and less than 0. Then and this is x minus 1, so this will be equal to minus 1 only. So this will be equal to minus 1 if x is greater than or equal to 0. So now here, so we know that all polynomial functions are continuous. All polynomial functions are continuous in their domain. All polynomial functions are continuous in their domain. So these functions for x less than minus 1 and from minus 1 to 0, and for x greater than 0, these functions are always continuous. So we need to check only at those points where the definition of the function changes. So therefore now at x equal to minus 1 we need to check. So now therefore the left hand limit, that will be equal to limit x tends to minus 1 minus f of x, that is equal to limit h tends to 0 f of minus 1 minus h. So that will be equal to 1. That will be equal to 1. That will be equal to 1. And right hand limit of the function at x equal to minus 1, that is limit x tends to minus 1 plus f of x, that is equal to limit h tends to 0 f of minus 1 plus h. So when it is slightly more than h, so we have to use this definition, that will be limit h tends to 0 minus 1 minus 2 into minus 1 plus h. So here if I put h equal to 0 here, this will be minus 1 plus 2, that is equal to 1. And f of minus 1, that is also equal to minus 1 minus 2 into minus 1, that is minus 1 plus 2, that is equal to 1. So therefore limit x tends to minus 1, limit x tends to minus 1 f of x, that is equal to f of minus 1, which is equal to 1. So we can say that, so the function f of x is continuous at x equal to minus 1. Function f of x is continuous at x equal to minus 1. And then we have to check at x equal to 0. X equal to 0 we have to check. So the left hand limit, that is equal to limit x tends to 0 minus f of x. So that will be equal to limit h tends to 0 f of 0 minus h. So when it is less than 0, we have to write, that is limit h tends to 0 -1 -2 into minus h. So that will be, so I can put 0 here. So this will be -1, and therefore right hand limit that will be equal to limit x tends to 0 plus f of x. So that will be equal to limit h tends to 0 f of 0 plus h. So that will be equal to, so we can put h equal to 0 here. This will be limit h tends to 0 -1 minus 2h. So that will be -1. No, h is, so when it is greater than 0, I have to use this -1 only actually. We have to use the third function, that is -1, and which is also equal to f of 0. So therefore we can say that limit x tends to 0 f of x, that is also equal to f of 0, which is equal to -1 here. So we can say, so the function is continuous. The function is continuous at x equal to 0 also. So it is continuous at x equal to 0 and -1 also. So therefore we can say there is no point of discontinuity of the given function. Hence we can say there is no point of discontinuity. There is no point of discontinuity of this function f of x. And so it is, and so it is a continuous function. So it is a continuous function. So hope you have understood the concept. Thank you.